Hi, I'm Bob Hochmuth and I serve as a regional specialized extension agent here in the Northeast District and work with commercial vegetable crops both in the greenhouse and out in the field. We're going to be able to present to you a little bit of information about our lettuce research and extension program here at the North Florida Research and Education Center, Swanee Valley. We've been working with Dr. Sandoya on the Emerging Enterprises project. And in this case, the emerging enterprise is hydroponic or greenhouse grown lettuce. We've been working with Dr. Sandoya on several different releases of his program or breeding lines in his research program and comparing them to commercially available lettuce cultivars. We've been doing this research in 3 different production systems: nutrient film technique, vertical culture using Vertigrow as the production system there, and our small floating raft system, which sometimes is called deep water culture. We're going to present to you the growth stages, 2 different stages. Wanda Laughlin, our greenhouse manager here, is the one that is doing the day-to-day activities with these 3 production systems, and we're going to follow Wanda along a couple of different points in the growing stages of lettuce. One in the middle of the production system and one towards the end near harvest. So we welcome you here to our video series, and we're going to take a look at the lettuce breeding program here in our Emerging Enterprises program. So let's get started and see what Wanda's got cooking today.
Hi, I'm Wanda Laughlin. I'm the greenhouse manager here at the North Florida Research and Education Center, Swanee Valley. And we're going to talk about some of our lettuce systems today. And the first system that we're going to talk about is our NFT system, which stands for Nutrient Film Technique. This is a popular system among hydroponic growers for the production of leafy greens. And today we're standing in front of a crop that we're evaluating for key factors in lettuce. And we're comparing some UF breeding lines against some popular industry standards. This is a channel system. It's a closed loop system, also known as a recirculating system. So each channel houses 15 growing spaces, and they are irrigated from a small spaghetti tubing at the top end of the channel, and then they recirculate into our chilled reservoir. We have 30 varieties in front of us today, and we have 4 types. So we have a set of romaine types, then we have our Boston types, we have little gem types, and then at the end we have our leaf types. And you can see among these lettuces that there are a lot of variations in color and leaf texture. In this crop, we're evaluating for characteristics such as color, texture, tolerance to environmental conditions such as tip burn and early bolting, as well as their growth habit. This crop was planted in a rock wool growing cube. This is a media that is engineered to have a good ratio for water to air holding capacity. There's no small particulates that can fall away, as in loose medias like a peat mix, that can clog up our system. So this is a very clean system. You can sow directly into your rock wool cubes, and then as soon as you have a viable root system on your cube, because these are flat bottom, you can put them directly into your system. So within 2 weeks you can get your cubes into your growing system, and then within another 2 to 3 weeks, depending on the variety and the type of lettuce that you're growing, you have a mature head. These types of lettuces are sold sometimes as live heads with the roots attached in a clamshell. We evaluate for different types of characteristics, such as how easy are they to harvest, or does the head stay intact when you harvest it. So those are other things that we're looking for. This is an easy to clean system. You sanitize it between crops and you're ready to plant again. I'm going to lift one of the heads of our growing channel so you can see the inside of the system. So suspended, you can see our small root cubes. This is a 1-inch cube, and it's got a good root system on it. One of the challenges in the system is keeping the system from having leaks, which can drain our reservoir, and also eliminating any sunlight from getting into the system, because where sunlight hits nutrient, you're going to develop algae. Algae is one of the biggest problems in these systems. It can clog the system. It can also grow other organisms, so we try to keep algae down to a minimum. We also don't want it robbing our oxygen and our nutrient from our plants. So excluding light is very important in this type of a system. There's less reason for us to have to spray because we don't have any contact with the soil. We're inside a greenhouse, so we have minimized our insect pressure. It's not excluded, but it is lower. So we have less pressure on us to put chemical applications on these crops. So we're going to follow this lettuce for the next couple of weeks. These plants have been in this system for 13 days today. So they are at their halfway point, and in 2 weeks we're going to come back and we're going to harvest and show you how we harvest these guys. We are back in our greenhouse. It's 2 weeks later, and we are at the harvest stage of our lettuce crop that we've been evaluating. You can see that it has grown considerably in the last 2 weeks. We've had close to ideal temperatures for lettuce indoors and outdoors. So we've had moderate temperatures in the day, highs in the mid 70s. It's gotten a little bit into the 80s in this side of the greenhouse, and we've had low temperatures in the low 40s even. And the lows in the greenhouse usually run into the 60s and stay that way. So we've had really good lettuce growing conditions. So let's see what we've got. We're evaluating these varieties for set characteristics such as color, texture of the leaf, tip burn, density of the head, and bolting, which is going to maturity where they actually elongate, stem elongates, and it wants to set seed. So as we have been growing this crop, we can see that we've got a lot of variance in color, from a very dark green to a kind of a silver leaf green to a very light, bright lime green. And as the crop matures, these characteristics become very obvious, and it is very easy for us to evaluate the differences between the same types of lettuce and then the differences between different types of lettuces. So these are our romaine group here. We've got our Boston butterhead group. We've got our baby gem type, our little gems, and then we've got our loose leaf types at the end. And as we come through, you can see that we've got good height and structure on these. We look for root development as we go, so we can see that we've got good strong roots on these plants. And since these are ready to harvest, the roots aren't, as important to me at this moment, because these guys are ready to come out of the system. But as it started to mature, you can see some of the characteristics that we've been looking for are really presenting themselves now in these late stages. So we can see that we've got some tip burn. A lot of the heads are starting to come together and become more dense, which is something that we also evaluate for. And a lot of times tip burn hides inside that closed head and you can't see it. So as we're harvesting and we're taking data off these crops, we actually open up the heads to see what the younger leaves look like. So as we come down, we can really see some striking differences in these types of lettuces. So this is some of the baby gem types. These are mini romaine heads. They don't take as long to grow, but they really are sensitive to tip burn. So we've got certain varieties that we knew kind of coming in after harvesting 3 different times, growing 3 different crops, that we were expecting this to see what time it presents. So we're taking notes, so we can keep evaluating these, and that's what the breeding programs are all about. This is our indoor NFT lettuce, and we can now go outside and look at some of our other crops.